Alright folks, we're doing abbreviated electron configurations. This one's going to be short. It builds on everything that you've already done with the other electron configurations. So we're going to just take it away. In all honesty, I'm a chemist. I'm lazy. I also want to avoid mistakes. It's really easy for me to make mistakes. And I probably made some of these podcasts. Hopefully you've corrected them. Bottom line is, again, remember that the electron configuration is determined by the distribution of the atom's electrons among levels, sublevels, and orbitals based upon a set of stated principles. And you should be able to take your periodic table and label these as 1s, 2s, 3s, etc., 2p, 3p, 4d, 3, all of those kinds of things. You should be able to recognize that. If you can't do it, take out a periodic table right now, write this stuff down, and make sure that you can do that. If you don't understand it, please come see me in class. This is critical. What I would like to do is would like you to pause the video and create the electron configurations for the first 3 of these. If you want for the practice, you may do the last 2, but I'm only going to do the first 3 of these as far as during the podcast. Okay? So go ahead. All right, welcome back. Neon is 1s2, 2s2, 2p6, because neon is number 10, and that's 10. I have for argon 1s2, 2s2, 2p6, 3s2, 3p6, and krypton 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, sorry, 2 goes up on top, 4s2, 3d10, 4p6. Okay, so that's as far as I'm going to go. What do you notice? Well, I notice that this one ends in 2p6. What can you tell me about the rest? This one ends in 3p6. This one ends in 4p6. So we have filled up our p levels. What do you think xenon's going to end in? Yep, good guess. 5p6. And how about radon? 6p6. And I didn't have to do any work to figure that out. So, the noble gases are very important, and that's what we base things on. And they all end in p6, except for helium, but we're not going to worry about helium right now. The bottom line is we can use those as we look towards what other electron configurations are out there. Because the electron configuration for neon never, ever changes. So, let's look at sodium. Sodium is number 11. And so let's look at the full electron configuration. 1s2, 2s2, 2p6, 3s1. This is number 11. Well, what noble gas came before sodium? So if I start with sodium and I start working my way backwards, what's the first noble gas I come to? Sure, it's neon. And if I remember neon's electron configuration, it's right there. It's those 10 electrons, and it's never, ever, ever going to change. So my abbreviated electron configuration can be neon followed by 3s1. Now, I cannot do this for neon. If I wanted to find the electron configuration for neon, it would have to be the previous noble gas plus neon. So, bottom line is our abbreviated electron configuration goes back to the last noble gas, puts it inside these square brackets, and then anything that comes after that is what we just pulled out. Much shorter way to write electron configurations, especially when we get down to the bottom of the periodic table. Right? So, pause the video, see if you can do magnesium on your own, then come back. Alright, magnesium, the last noble gas before me was neon, and then I count down and I see that I am in my 3s level, and I need 2 electrons. So that's it. Alright, pause the video, see if you can do all these, and then come back. And I'll do them. Remember, you're doing abbreviated electron configurations. Okay, that's the first one. Carbon. Helium, 2s2, 2p6. Calcium. I can go back to neon. And from neon, I can then do... Sorry, my bad. For calcium, I can start at argon. I got 1, 2, 3, 4. So I'm at 4s, 4s2. How about titanium? Very similar to calcium. It's still going to be argon. And it's going to be 4s2 because I filled up the s. But then it's going to be 3d2 because that's titanium. How about zinc? Same line, real similar. Argon is my last noble gas. 4s2, 3d10. Now with silver, well, that one's going to be a little bit more complicated. That one starts at krypton. And from krypton, we go to the 5s level. And then we go to the 4d level. And in the 4d level, we have 9 electrons. All right. Can you work them backwards? All right. Again, pause the video, see if you can work them backwards. All right. So simply, I look at this top one and I say, this is helium plus 2. Well, helium plus 2 is beryllium. Here I've got neon plus 3. Neon plus 3, neon's 10, plus 3 is 13. This is aluminum. Argon. Argon plus 7 is going to be iron. 1, 2, 3, 4, 5. Yeah, it's going to be iron. Krypton. Okay, let me go back. That's wrong. That should be manganese. I can't count. Okay. And how did I catch that? Well, I took argon. Argon was number 18, and I added 2 for 20, and I added 2 for 25, so I should be at number 25. All right. Krypton plus 2, plus 10, plus 2. Krypton plus 2, plus 10, plus 2 is going to be 10. And then xenon, going all the way up to what ends in P3 is going to be this one. Alright, I think that's it. So you should be able to create an abbreviated summary configuration for create an abbreviated electron configuration for any element. You should also be able to do it backwards. Okay, that's it. We're done with abbreviated electron configurations. Do your worksheet. If you have questions, please see me in class. Have a great day. Bye.